tutorial is about optimizing a project. And the idea here is you've built a project and you're trying to save it or push it out to some people, and you want it to be as efficient as possible. There are two reasons why you would want to do that. The first is reducing complexity for future edits. And what happens here is you're building a project, you've played around with some calculations, you've loaded some tables that you're not using, you set up some links and you took the links out or you're not using them and so forth. So you'd like to get that out of there. Otherwise, when somebody in the future tries to go and edit the project, it can be pretty tough. And there's actually another tutorial called Save the Project Schema, which shows you how to get the metadata of the project out into Excel sheets or a PowerPoint so you can basically have a document, in which we strongly recommend if you're putting a project into production, having a document somewhere that defines what was done to build it and what the core essence of it is. The other reason to optimize is for performance. So our target is to have a project up and running in 10 to 30 seconds, whether you're on the client version or the web iPad version. And there's another tutorial here titled Automatically Refresh Data, which talks about pre-staging and loading the data. By doing that, we have a much more efficient, fast load time in this range than if we're loading live from the database, where we're derivative of the write time of the database and network loading and all that. So that's worth reading to see how we get to that level. But the actual structure of the project itself will also help, which is what this tutorial is about. We also want a response time less than a second when somebody's interacting with the data in a project. And we want to make efficient use of RAM. So let's look at it. There are 4 things that you could do to make a project more efficient. The first is the actual structure of the project itself. The second is there's a bunch of, actually we call them no-brainers. Get rid of the stuff you're not using. The third is discretion. There's some things that are going to take up a lot of RAM, be big, and you want to look at them, and they might be the things you actually want in the project, or there might be a better way of doing it. And third, there's some tips and tricks. So we're going to just walk through these, and we're going to show how the software project workshop can help you manage this and find these things. So first, project structure. For us, good design is a project that addresses a business need or theme, and then it's comprised of pages that are set up to tackle the different topics or issues, and they're usually grouped into themes. Like if it's promotional effectiveness, you probably want 2 or 3 pages on the promotions, showing when they were sent, which ones were most effective, what the messaging was. You might want then 2 or 3 pages on the customers who got these promotions. What level of buyer are they? How often have they bought? Where are they? Who's managed them? All of that stuff. So that's the idea. Then on each of those pages, the workflow becomes the pages. Then the charts you tile on the page support the workflow. But what happens is a concept of creeping complexity. So we have found that somebody wants an additional page, somebody else wants another page, somebody else wants 3 more charts, and pretty soon what had been a clean project has morphed into something way too complicated. And so that creates user complexity. It also slows the project down because you've just got more data, more pages, more calculations. So part of this is the design of the project itself. And we have other tutorials, and our consulting and training helps with that. But so now you've got the project at the level you want it, and you've managed it. There's some no-brainers. There's a bunch of stuff that doesn't get used. Tables you brought in that are no longer being used. Fields in the tables that aren't being used. You just don't want to load them anymore. They're just taking up RAM and space. Calculations that were set up that aren't being used, and at start time they've got to get calculated, and if it's big tables, that can take some time. And roll-ups. You created derivative tables that are rolled up. They're taking up RAM. We note here that links and copies might also want to be looked at because they increase project complexity, but they're very efficient. They're not going to slow the project down. For example, we store strings. If there's common strings in different tables, we store them once, and then we index to them. If you do a copy, so you're moving a field from one table to another logically, it looks like it's been moved. It actually has not been moved. We're just indexing to it, and we're not saving it another time. It's just saved once. So we're very efficient at that. So these aren't going to improve your performance by eliminating unused links and copies, but they will help with editing and complexity. So let's look at where you'd find these things. So I'm opening, here's a project. It's on a page. The project workshop is where all that is. So 2 ways to get there. On the left, task view. This takes you through loading data, designing pages, working with data. Here's the project workshop. I click it, I get a page. The other place you can get it is up here from the view menu, project workshop. Depends how you like to find it. But this details my project. I've got 21 tables, 17 were loaded, 4 were rolled up, 15 pages, 1 color model, 24 calculations, cross-table links, data. So all this stuff is here. So if I want to look at the tables, I click Tables, and here they all are. And I can see if they're in use or not. If they're not in use, I probably want to go to my, my data source and edit them out so they're not loaded again. I can click on an individual table. Let's pull this down a little bit, and let's look at the affiliation table. So here's a table that was loaded. The table's in use, but it's got several fields here that aren't in use. This one, and 3 of them. By the way, at any point I want to see where it's in use, I can click the yes, and it's showing me that that field's in use in a bar chart on the affiliation page. So I can go and find it, and it's a dependence called class year. But if I want to get rid of these things, I can go to modify the table at its source up here. I get basically the source load wizard for this table, connection, and then the metadata. This is telling me all the fields that are in that table, and I'm loading them all right now. So I'm being presented these fields, and I'm loading them all. If I wanted to stop loading them, I just uncheck them, and at this point I'd probably grab the 3 that aren't being used and get rid of them, and then I click refresh and save, and next time I load the project, they won't come in. The memory won't clear out until you reload the data. But the next time it loads, it won't be there. They'll still show in the wizard here. They'll just show unchecked. So if I actually want them back at some point, if I'm presented columns in the table that I'm not loading, I can just check them here. Then on the next load, they'll come back. So just similarly, if I go to the pages, obviously they're all being used. I can do some things with them here. Color models, I only have 1 that's in use. Calculations, got a whole bunch of them. Some of them aren't in use. I can edit them, or I can just get rid of them. Here's what I'd want to do. Cross-table links. We want to look at the roll-ups. I've got 4. They're all in use. Data hierarchies, they're in use. The date fields, they're in use, and so forth. So that's a pretty good run-through the project workshop, looking at where you can find things that aren't being used and get rid of them. The next thing is looking at big things. And there's generally 3 or 4 of these. Monster charts. So I've actually built a project where I put a bar chart on like 600,000 things and stacked color into it. So in that case, the chart is going to take a memory footprint because it's got to calculate all the aggregations and then calculate all the stacking for the colors. You might or might not want that, but this is going to tell you that's something to look at. Large tables. Also in here within large tables will be large amounts of string fields. And then summary sheets. So our summary sheet is meant to be, an aggregate report level chart. If you put a summary sheet, it's not designed to show 400,000 things or 100,000 things. It's not a good use of the summary sheet. You'd be better off using the data sheet. So you might want a summary sheet on something large. Just be aware it's going to take RAM and it's going to be slow to open. So let's see, where do we find big things? Go back into the project workshop. There's a tool up here called the Data Pool Visualizer. If I click this, it's doing a mapping of the RAM, and it's showing me what's using memory. So here's the whole project. The project loaded is 404 megs of RAM. That does not include the application and maybe some other things, but that's the manageable part of the project that you have control over. It shows as tables is by far number 1, and it gives you the percents. If you let the brush up come up, that's 70%. Charts are 8%, but there's still a chunk, and then it falls off pretty dramatically. So here's a heat map looking at the tables, and I can clearly see that GIFS 2 dominates. It's taken up 131 megs of RAM. I should consider whether that table is something I really need. I might want to look at fields in it. It might be that some of my strings here aren't that big, but there could be some big string fields coming in with this table if it's got a lot of rows. So that's the next level of discussion here. And again, this is perfectly fine, but it's telling me this is using a bunch of RAM. If I go here to charts, I see I've got one component. This looks like there's a bunch of smaller ones I don't even barely see. So there's one component dominating. Let's click this one. So this is a coming in from this GIFS 2 table. It's component. It's a chart. It's a bar chart. Title. Okay, individual hard credit. Well, this is on this big bar chart page I set up just to kind of prove a point. But this is a bar chart it's sorted by size. It's got a few on the left and gets really, so let's zoom in on this. So you can sort of see there's a lot of individual bars it's drawn, and way over on the left there's a few, there's like a little cluster that are significant, and then it falls off. Well, this is taking up like 32 megs of RAM. It's a bad use of a bar chart. It's just, you know, if it was just the data on the left, it might be good, but this bar chart doesn't tell me anything. And the Project Workshop data pool over here highlighted that this is a potential problem. So I probably want to just get rid of this page or restructure it. Let's just get rid of the page. Yeah, that's gone. So this data pool visualizer, if I restarted and reran this, it's going to remap with that taken out, and I would have just dropped 33 meg of RAM. So that's the data pool visualizer, and yeah, to reset it again, you need to restart the project, and then it will remap the use of the memory. And you also, another point, and the PowerPoint mentions it, to use the data pool visualizer, you need to open all the pages first, because the way we allocate RAM when we open a project is we only allocate what's there, and we save the load of the subsequent pages and charts until somebody goes there. That keeps our memory footprint down, and it speeds the startup time. So if you use the memory pool visualizer and you've only opened one page, it's going to look at the memory footprint of what the project state it sent in. So to see the entire project fully opened, you need to click on and visit all the pages, and then it will map out. That's what this means. And then there's some tips and tricks. So to be efficient, you want to load from an ADVM, not an ADV. The automatically refresh data tells you how to set this up so it loads on a trigger or loads periodically and gives you that. Again, the ADVM is a much more efficient form. The issue is when we load raw out of the databases, we're just loading tables in. When we compress into the ADVM, we can eliminate spaces. We can store strings one time across multiple tables. There's a whole lot we do to be efficient. And so an ADVM project with, say, 30 or 40 million rows of data will take half as much RAM as the ADV of the same size. So 30 million rows, a few hundred fields, might be a 4-ish gig footprint fully loaded. The ADV could be 6, 7, even 8 gigs, depending on what the data makeup is. So this is going to be a substantially smaller RAM footprint. And this thing will generally load in 10 to 30 seconds, where the ADV is relegated to the right speed of the database, and that can slow in the day if there's a lot of people on it, in the network transit time. So this often could be a 10, 15-minute load. This is going to be a really quick 10, 30-second load. So big differences here. The next tip and trick is avoid string keys. Integers are best. Doubles are next best. So when we're keying across the tables, integers will take less RAM, and the response time will be much faster. They're easier to key on. Double bytes will be next, and string keys are the slowest. And sometimes it's not possible to have an integer index. It's going to be a string. And we've seen cases, though, where there's 3 million keys, and 2 of them are sort of bad data and have strings in them, and 2,998,000, whatever, are integers. So in that case, we convert to integers and just not use the bad keys, because they're bad keys anyway. So you just got to look at this when you're loading, and you generally want integers for the keys. And the last is roll-up aggregation is more efficient than charts. So the issue is with large data sets, and let's say we're talking 20 million or more rows, it helps to set up the charts that aggregate, which is primarily the bar chart and the summary sheet, on rolled up tables rather than at the transactional level. So we just had an example of this. For example, put the charts on a roll-up of invoices instead of the invoice line level itself. So we had a transaction table that 100 million invoice lines, and I think there was something like 800,000 invoices. So you can do the math. There's like 100 to 1 ratio there. So it was complex invoices. Well, the problem is a bar chart or a summary sheet operating at off the 100 million invoice line level has to aggregate that. The charts do the aggregation individually into the 800,000 invoices that then get listed or charted, and then stacking colors in if it's a bar chart. That's not as efficient as if you use the roll-up tool to take the invoice line table and create a separate invoice table, put the charts on that, link them together. Then you can still have the detailed invoice line level in a data sheet for when you actually want to get to the detail. So just a trick for larger data sets that makes it more efficient. The bar charts can do the work, and so can the summary sheet, but it's just not as efficient. And that's also a case where, a summary sheet on 800,000 invoices might be the right chart. Back to the other page, it's going to be it's going to have a slower response time than on a smaller set, but it'll be doable and workable. And so again, these last ones are discretion. You're looking at the actual goal of the project. You're seeing some things that could be optimized, but these are choices you need to make and trade off the actual purpose of the project with the performance. We know that doing these things will make it load faster, or run faster, use less RAM, but you might choose to keep the large bar chart or to keep the large summary sheet or whatever, because that's the way you want the project to work. These things clearly are no-brainers. You just want to get them out, and good project structure is important no matter what. So we kind of tiered this from the things you really ought to do every time to the things that you want to look at and then do the right things with. Thanks for your time. Hope this was helpful.